Hello, everyone, and thank you for attending today's webinar. Webinars are bandwidth intensive, so closing any unnecessary browser tabs or windows running in the background will help conserve your bandwidth. Some networks cause slides to advance more slowly than others, so logging off your VPN is recommended. If your slides are running behind, pressing F5 on your keyboard will refresh the page. If you have any questions during the session, just click the Q&A widget at the bottom of your screen. We will answer as many questions as possible during the Q&A session. If we are unable to get to your question, we will reach out after the presentation. Additionally, we invite you to view the resources section for supporting materials related to this webinar. Immediately after the questions and answers section of the webinar, you will be prompted to fill out a brief survey. We encourage you to fill out this survey as it helps us determine topics for future webinars and create a better viewing experience. This content is GE Vernova proprietary and copyrighted information and should not be used or distributed without further written approval from GE Vernova. Additionally, this session may be recorded for further use by GE Vernova. With that, I'd now like to turn the presentation over to Jeremy Weatherby, the moderator of today's webinar.
Good morning, good afternoon, good evening. Thank you for joining us for this next webinar on driving CCS forward. The time is now. It's my pleasure to welcome you to this session, and we're going to go through and have a very interesting discussion around our net zero Teesside project in the UK and some of our key panelists that are key participants as part of this project. So we're going to take a moment to introduce myself. My name is Jeremy Weatherby. I'm at GE Vernova. I'm the carbon solutions leader that's focused on decarbonization of our gas turbines. Now I'm going to hand it off to Julie Kranga from the 10 Energies team.
Thank you, Jeremy, and hi everyone. I'm Julie Kranga from Technip Energies. I'm leading our decarbonization solution business line, and I'm the sponsor of the NZT project.
And Jackie?
Hello, everyone. My name is Jackie Fisher. I'm a BP project manager, and I'm responsible for the Net Zero Teesside Power Scope. I joined the project just prior to sanction, and I took the project through to financial close. So really looking forward to speaking today.
Thank you, Jackie and Nick.
Thanks, Jeremy. So Nick Flynn from Shell Catalyst and Technologies. I run Shell's technology licensing business. We have about 40 or 50 technologies, but today we're here talking about the CANSOLV technology.
Thank you, Nick. And to give you an understanding of what we're going to go through today, we're just going to take a few minutes to kind of walk through what is carbon capture. Then we're going to get into a panel discussion where we have a few pre-prepared questions for the team. And then we want to hear from you. What questions are on your mind, and take advantage of the expertise and the knowledge of all the individuals we have here today. So why is carbon capture so important? When we think about the energy industry, we're facing a time of unprecedented growth and demand for energy. But then energy needs to meet what we call this energy trilemma. It needs to be affordable, it needs to be reliable, and most importantly, it needs to be sustainable. And how do we balance all of those three things, given the challenges we have ahead, where everyone in the world is looking to use more energy, but that energy needs to be clean? One of the ways we can do that is using carbon capture. And carbon capture is an absolutely proven technology. Already today, there are already over 70 projects operating, capturing carbon of over 60 million tons on an annual basis. So this isn't like some new thing that isn't happening. It is happening today, and it's happening at scale. Also, one of the key questions that we get is really around, is this technology mature? Can we use this technology? This technology has been around for over 50 years. So while today we're going to talk about its application on a gas turbine, which is new, this technology has been in existence for a very long time and is definitely proven. And then the last piece about this is, how do we make this viable? We are seeing policy and incentives come into place that can help drive these projects forward and make them financially viable so that we can see more and more of these projects go into operation. So we're here today, most importantly, to talk about our Net Zero Teesside project. This is one of the first projects at scale on a gas turbine that exist in the United Kingdom. The UK has set up a specific strategy to create these industrial clusters to focus on decarbonizing these main centers that generate significant amount of carbon. By having projects like the Net Zero Teesside Power Project, we're now going to be able to provide power to those industrial clusters, significantly reducing the carbon footprint and applying technologies from both Shell and their Kensolve capture technology, the engineering work from Technip Energies, and GE Vernova, where we're looking at applying technologies like exhaust gas recirculation, where we can increase the carbon concentration coming out of our gas turbine, making the capture system more efficient and actually driving a higher capture rate. This is truly a landmark project where we can provide significant amount of power and also reduce over 2 million tons of CO2 annually. So from here, let's get into the panel and start having a discussion on what made this project viable and what some of the biggest learnings were. So Jackie, you're coming in on this project. What are some of those key things that we've learned from the Net Zero Teesside project that you can share?
Thanks, Jeremy. So there's 4 key areas that we took away that were successful to getting our project through to a successful financial investment decision, or FID. So one of the key items was government business models. Through collaboration with the government, we were able to agree a dispatchable power agreement, which supported the project development and ultimately the sanction, which we'll touch upon more later. The second would be investment. So we created bespoke structures and worked with financing partners to be able to give confidence to investors in what we were doing. From a land and consenting perspective, we went through a very detailed public consenting process to ensure that we had the backing of all of our stakeholders. And fourth, and most importantly, from my perspective, technology and supply chain. We created a structure for the multi-billion-pound contracts, including the carbon capture technology, which gave confidence and supported local content. And we'll keep the focus here for a minute to focus on the consortium perspective within these 4 points. So focusing on technology, which is critical for our project, especially being first of a kind. Solvents. During FEED, we tested various non-proprietary solvents and came to the conclusion that to get a high capture rate and manage the risk of degradation, we would need to have a proprietary solvent to achieve the performance required to underpin our project. Thus, for solvent choice, we needed to ensure that we had a proven option on the table that had both commercial and industry experience, which is where Shell comes in, which has Laxness and Boundary Dam in Canada, which both showed proven commercial operation. And then from a contracting perspective, one of the key factors for the project was the integrated performance guarantee. So this is the guarantee that captures across the power plant through carbon capture to the compression and ensured that we had holistic value across the chain and gave confidence to our stakeholders that we could deliver what we were promising. So I think, Jeremy, those are our 4 key points. And with that, I'll hand back to you.
Thank you, Jackie. That is a very challenging situation to coordinate all of those various parties and the technical capabilities. So why don't I take that same concept over to Julie? To deliver a project like this at scale with all these different technologies and first of a kind, what is it like to work as a team across these companies and works with the government, to make a project like this possible?
I think, Jeremy, I'd like to do first a little bit of history. So this project was initiated in 2019 as a pioneering initiative to create the first decarbonized industrial cluster in the UK. And at that time, there was a consortium of several major oil and gas companies that decided to support that project. Teesside was selected as an ideal location for a large-scale power plant with carbon capture. At the same time, the UK became one of the first major economies to legislate a net zero greenhouse gas emission target by 2050, And the UK government announced then that they will fund CCOS development with very significant support. And this support was confirmed in 2024 with the announcement of the 21.7 billion funding package over 25 years to support CCUS project in Teesside and INET clusters mainly. So yeah, it's long history, and we see all what it takes to get there. So really, this NZT project shows that with the ambition and the collaboration, we can do extraordinary things. And with this idea of maybe more than a project, a kind of shared mission across the different stakeholders that are involved, including local authorities, communities, and companies like us. So from the Technip Energies standpoint, we bring our global expertise in project execution, in carbon capture projects, our alliance with Shell Catalyst and Technologies. And we are as well learning a lot from new partners like Vernova in particular. And we strongly believe that the energy transition requires a system thinking approach, that no single company can manage that alone, because nobody has all the skills and experience to do it. So what's pretty striking in this project is the level of transparency and trust and shared purpose that we are developing among all partners. This collaboration is very proactive and solution-oriented at all level, being a technical level. You mentioned some new technologies like the EGRs that are developed on this project. There are a lot of interfaces to manage, but as well on I would say contractual level, and as well relationship with the authorities. This is possible only because of a very collaborative and solution-oriented mindset. So to conclude my answer to your question, I'd say that for those listening to this webinar and maybe thinking about how they will decarbonize their own project, I think NZT is really a model to learn from. Collaboration, public-private, collaboration among private companies, shared accountability and risk, and I would say a focus on delivering this flagship project. So this is currently happening. As we know, we've entered the construction phase, and this is happening because we are doing it together.
Thank you so much, Julie. I loved your comment around a common mission. And I know from the time I've spent working on this project, it's exciting to see how each of the companies are bringing the best ideas, the best concepts together to make sure that this project is successful and that we're all focused on the same end goal. And also love the idea of the systems of systems on how we work together collaboratively to optimize the overall plant by doing the trade-offs between not only the power plant, but also the carbon capture system. So Nick, coming to you, Shell can solve carbon capture. You know, lots of folks look at doing carbon capture on a gas turbine as a significant challenge. As someone who's coming in and providing, the core solvent for this technology, what gives you the confidence that this system is going to work in this sort of application?
So yeah, absolutely, Jeremy. Why are we confident in amine? So let me go back a little bit. Amine is an incredibly established process and technology that we've modified for CO2 removal. We've been licensing amine applications, particularly in sulfur dioxide treatment, for over 50 years, sorry, over 30 years, back in the 1970s. And we've done over 500 applications and licenses. So as Jackie mentioned in her kind of talk, having confidence in the technology is super important. Not only that, we have 2 operating plants, both of them been in operation for over 10 years. We have one in Canada, one in South Africa. The Canada one is the bigger one. It's in Boundary Dam. It's a coal power station in Saskatchewan. It's about 1 million tons per annum, and it's been operating for over 10 years now. The South Africa one is a slightly smaller one. It's run by Brother Cesar. It's a gas boiler, and it runs about 150,000 tons per annum. And we have, with our colleagues in Technip Energies and with GE, we've got multiple projects that are reaching or just passing FID, with NZT being the one that we're talking about today. Maybe just to give a little bit more confidence as well. When I first started as a young process engineer on a refinery in the UK in the mid-90s, 30 years ago now, amine absorption and desorption was a technology that we were using then. In fact, my first job as a technologist was to look after amine units on this particular refinery. So that just goes, you can it's relatively well known and understood how it works. Now, people are saying it is first of a kind of a technology. That's not actually true. It's first of a kind in the value chain. As you add all of these things together, it becomes first of a kind. The actual technology around how you get the CO2 out of flue gas and how you turn that into a pure stream you can sequester or do other things with, that piece is actually relatively well understood and known.
Excellent. Thank you so much, Nick. Coming from a power plant perspective, when we look at the integration of a gas turbine to a carbon capture, it also looks like a combined heat and power project. So this is experience and knowledge that we have. And as you highlighted, amine system, carbon capture, gas processing, decades of experience in this sort of processing gas and taking carbon capture. So there's really nothing that's truly novel here except the overall integration of the value chain.
Right.
So thank you so much. Jackie, I'm going to come back to you. You made this comment in the beginning after answering your first question around a dispatchable power agreement. That was really critical to move this project forward. What is a DPA or a dispatchable project agreement? Could you explain that a little bit more?
Yes, of course. So a DPA or dispatchable power agreement is essentially a government-backed subsidy agreement. And it utilizes the offshore wind CFD framework, and it adapts it for combined cycle gas turbines or CCGT with carbon capture. It provides the basis for the actual contract capacity payment revenue support, which in turn provides confidence in the revenue stream to support investment. Critically, because it's based on the wind CFD and capacity payment, it's a bankable project. It's a bankable product, which enables third-party financing. The government-backed subsidy with project financing returns makes an economic investment, which then in turn makes the project economically viable. The project value chain is dependent on the UK government support for the Transport Regulatory Investment Model, or TRI, another acronym for you, which is a regulated asset model for CO2 storage, which enables the NEP, or Northern Endurance Project, to be progressed, and our project, NZT, to store carbon capture or carbon dioxide. The 2 discrete business models, DPA and TRI, puts the cross-chain risk, CO2 storage, with the government. And this ensures that our project has a reasonable amount of risk and can be backed by investors to move forward. And this in turn supports the government's 2030 goals to decarbonize the energy grid, because if you can capture 95% of the CO2, that means you can have 20 NZT power plants up and running, which would be equivalent to 1 non-abated power plant. Simple. Over you, Jeremy.
Yes, simple. Thank you so much, Jackie. Clearly, it's obvious that these early projects are going to require some level of government support. So I'm going to look to you, Julie and Nick. What if you're in a situation or you're developing a project where you don't have that same level of government support? How do you see that working?
Jeremy, I can start to give some element of answer. So we very recently inaugurated small carbon capture plant in Norway for a client who is a project developer supporting waste to energy companies to decarbonize their operations. And the beauty of this development is, and to name it, it's carbon centric is our client. They managed to build a business case by selling the CO2 that is captured. It's a food grade CO2, so that can be then used for the agro business. And they managed to make this project economically viable with only a very minimum support from some funding mechanism. So this is one example that shows in real life that we can make carbon capture and utilization viable economically. Another thing that we see a lot in the market, in the power, especially for our clients that are trying to address the need of data centers and hyperscaler, as they firm up their plan to develop quickly a new power supply for their customer. They are looking as well to decarbonize this power for at least for the midterm. So we are supporting a lot of clients to start to figure out what does it mean to decarbonize my gas power plant and to help them to mature their development. So then when they are ready, we can go as fast as possible to deploy carbon capture.
And if I may add a little bit more, Julie, onto that as well. You're absolutely right that we can't make these projects if they don't make money, if they're not investable and not bankable. And pretty much the two ways of getting that is either having some level of carbon tax, which penalizes people for emitting carbon. So that gives them one basis to it. The other way is looking at the differential of the product you make being a green product or an abated product versus a grey product, which comes with the CO2 being emitted into the atmosphere. There has to be some differential between those two. And we see in some industries, in particular in cement, that people are willing to pay a significant portion more for green products. And that's what's driving those projects to make them investable, to bring the revenue stream. Sadly, we're not in a place where we as companies can do it just for the kind of the moral high ground. We do it for shareholders, and we do it to make a good return on our capital. So those things need to happen in place. They're not happening everywhere in the world yet, but they're much more likely to go ahead once we start seeing these projects start to lift.
Great. Thank you so much, Nick and Julie, for that clarification. It's been an interesting discussion today. We've talked about the technology, we've talked about the government intervention, the financial backing that's required to make these projects go forward. So as others look at their projects and other sort of projects, could you maybe, Julie, highlight, what is the value of having an alliance or a coalition for some of these projects to help them go forward?
Sure, Jeremy. So I think a simple answer is that without an alliance or a strong partnership, this cannot happen. And why? It's because you don't have a team just by putting together some A players. You need to have a glue. And this glue happens when the different teams start to work together, develop a mutual understanding and respect for the different business and constraints. And when we create trust, and these are the foundations to create high performance. The technical challenges cannot be solved in such high complexity of project without this trust and this special glue that we create as an alliance. So I'd like to give some very specific examples. So this alliance and this consortium, so practically it's a consortium between Technip Energies and GE Vernova with Balfour Beatty, our construction partner in the UK, and Shell Catalyst and Technology as a provider of carbon capture technology. This is not a coincidence that we have been selected to deliver this project. Is because we demonstrated during all the development phases, starting with the FEED in 21, that we can work together and we can work together successfully and develop a robust project and then a robust execution. So I think that's very important. So this was demonstrated during the FEED. Technip Energies and Shell, we have an alliance for carbon capture since 2012 that we have strengthened very much in the past years, and we are now globally mutually exclusive. And because of that, we are now able to be fully transparent. And what does it mean? It means that we have such a level of trust that Shell share more about their technology. We share more about our prices, our different ways to integrate, etc. And with this, this is where we can really optimize the development and make the design the best for our client and for what's needed to develop a plant that is reliable and minimize the spend and the OPEX. So alliance is absolutely a must, and I'm 100% sure that none of those projects will happen unless you have a very strong team of players.
Thank you so much, Julie. And I love the comment you made around trust and how important that is to truly have those transparent discussions and be able to share information to drive the best solution at the end of the day. Jackie, as the project manager of such a complex opportunity and overall integrated project, I'd love to hear what learnings you have and what sort of things can be replicated on future projects.
So I think just linking this back to what Julie said about integration and the value of an alliance and the GE Technip consortia, we simply wouldn't have a project if GE and GE Vernova and Technip did not integrate well, right? So if you both did not integrate well, it would have resulted upon contingency, and it would have increased the cost and complexity of the solution. And we simply would not be where we are today, which is a sanctioned project that we're moving forward with. And this was key as well to linking back to the integrated performance guarantee. So by all parties having a seat at a table, it allowed you both to understand how the products would integrate well together and how you could make a promise associated with it as well. And this showed up throughout the mechanism to get where we are today, where you've achieved minimal startup times, parasitic loads, heat integration, and solvent performance. And that resulted in a project that we were able to take forward. So all those items pulled together and we're able to get the project across the line. And you can also argue that when we were to look back at it, you mentioned the EGR in the beginning, right? So that was an element that came up during the FEED where GE or Vernova took the problem away and came to the table with a new solution. And it's really great to see how that then plays in and will further throughout further solutions as we proceed to other projects, or when you proceed to other projects, I really should say. And if you guys didn't have a seat at the table, that might not have been a solution that came up, right? Technip might not have come up with that on their own. And that really shows the value of what an integrated alliance brings. I think looking back, as we negotiated the contracts and got to a technical agreement on how to proceed, there were a lot of elements which were new to all parties: Technip, GE Vernova, and BP, or the NZT integrated joint venture. And what was really critical to get through these was sitting down and discussing the detail and why our key drivers were what they were. And this allowed us to find solutions to be implemented and progress forward. It required each party to move slightly outside of our normal comfort zones. But I think by bringing it back to the alliance, because everybody had a seat at the table, we were all committed to finding a way forward that worked for all parties, and we were able to get there. And I think what will be really critical as we move throughout execute is maintaining these relationships and getting to the point where we successfully deliver the project. And this is different to what GE Vernova and Technip do separately, right? Everything needs to come together, be integrated well, and ultimately work together as an integrated plant and efficiently. So yes, I think there's a couple learnings in there. And back over to you, Jeremy.
Thank you so much, Jackie. And yes, we're looking forward to having a successful plant project in the future. So definitely want to extend my sincere thanks to all of my panelists, Julie, Nick. But let's kind of shift things up now and move to see, what's on our audience's mind. So with that, we'll go to the Q&A. Thank you, panelists, for a great discussion. Now let's get started into some of the Q&A that we have from our audience. Jackie, I'd like to start with you. When we think about, this project, the question is, I am interested to hear about the details of how government, private sector, and suppliers like GE, Shell, BP, and Technip came together to make this project happen.
Thanks, Jeremy. So I think I'll start with how the project came about. So the project is an outcome of the OGCI climate investments, which was a group of companies. And as part of this group, the project came up as an idea, and BP took on ownership of the project. And then we developed the project through our global concept development framework. And as part of this, we did a competitive feed where we went out to the market and we had GE, Technip, and other companies submit competitive feeds. As part of that, various consortia were formed to balance the power plant, carbon capture, and construction of the projects. And that's what brought together Technip, GE, and Shell as a consortia or carbon capture alliance for the NZT project.
That's great. Thanks, Jackie. And I got one more for you. And obviously, this is a topic that comes up often. Lots of folks look at these types of projects and see that the financial investment is quite significant. So the actual question is how to make carbon capture projects more attractive considering the financial investment is quite significant.
It's also key to ensure that you minimize the capital requirements as much as possible. And this should also come as more and more projects progress and you get more repeatable designs and more lessons that are learned into the project process. And this is one of the key things that came out of the CFD process for offshore wind in the UK, and one of the reasons why it was taken forward as a model for carbon capture. So
continuing on that theme, the next question I'm going to go to you, Julie. Clearly there's questions about the cost. The question that we have is, this project is obviously a first of a kind. Where do you see the major areas where we might see cost improvements on future combined cycle gas turbine and carbon capture projects?
Thank you, Jeremy. I think that's a very good question. So indeed, it's a first of a kind. And the next project combining CCGT and CCS will have better performance in terms of economics. They have to, because we need many of those projects to decarbonize power generation. So practically, how this will happen. So first, purely on the carbon capture part, we are working at productizing our solution. So we really need to industrialize those solutions, and for that we turn them into product. Shell, together with 10, have been working on those topics since a couple of years. We started by productizing the small units, work canopy units, and now we are looking at productization of the large carbon capture unit for power. So this is one part, and it helps to reduce capex, opex, footprint as well. And we have a very ambitious target reduction of about 30%. Then it's about the integration between the carbon capture and the turbine. So on that, we have several ideas all together with GE Vernova, and we are exploring those ideas. You mentioned during the webinar, Jeremy, about the EGR and how we can better integrate the EGR, but we have as well axis around integration, heat and steam integration, for example, and other pathways as well to reduce the cost around sparing and design philosophy. So in a nutshell, many ideas are there to help to reach a common target to make carbon capture more affordable.
No, thank you, Julian. I just will take a moment to kind of expand on that from the GE Vernova perspective. And I would say that this is just the beginning of our journey in this space. We've only started our initial discussions across our companies on where we see areas of improvement, enhancements, but this is just what we have today as far as our portfolio of technologies to apply. And holistically, we really haven't even started to invest in the next generation of technologies that can really optimize these plants even further. So we're starting today with this first of a kind to truly demonstrate that the technology is capable and be able to, do what it needs to do to capture the carbon. But we clearly see line of sight to significant further cost reductions and technologies enhancements to further improve not only the performance of these systems, but also reduce the cost significantly. So Nick, let me move to you on the next question, which I think is definitely one of the more significant, challenging questions that we got on the list. What policy changes do we need in the US and UK to accelerate investment decisions on the next set of projects?
Yeah, thanks, Jeremy. And I think this is probably one of the critical questions about moving CCS forward in this particular market. And let me first of all start by saying, in general terms, Europe and North America tend to go about it in slightly different ways. Europe tends to be more legislative and top down, and North America tends to be more create a competitive environment, and the best kind of solution will win. The bottom lines, most of the projects are really wrestling with investability. And in these first of a kind projects, can you really make enough money to satisfy what is the company capital hurdle rates that we need to get over? And I think we all recognize that some form of carbon tax is required. But carbon tax can't just be applied in one particular location or country or region. It needs to be applied globally. It also needs to take into account the fact that projects will get better as we deploy more of these. We'll get more efficient with our capital, get more efficient with our operational costs. And that needs to be taken into account on a bit of a sliding scale around carbon tax as well. Now, listen, we on this call are doing everything in our power to drive down capex and opex through many different ways to try and wring the investability out of these particular projects. But the governments in each of the individual countries and regions really need to kind of enhance their policies even more. And what we're seeing as well when we talk with the governments in these countries is they're trying to find innovative ways of making these policies bring these projects to life. I think everyone sees the need for it. We just got to find that perfect investability area.
Excellent. Thank you, Nick. So the next question, just because we've got such a great panel, and I think it would be very interesting from our audience to hear each of your different perspectives on this particular question. I'm going to start with you, Jackie. From your view, what is the one thing that you believe is holding CCS back or carbon capture back from scaling?
I guess the one thing from my perspective is a proven track record that others can then take on board the learning and give them a bit of faith that the projects can be competitive and deliver value to shareholders.
Excellent. Thank you, Jackie. And let me move to Julie.
So I believe that one thing that we need to collectively achieve is investability of those projects. So we discussed that at Technip Energies. We are working on the productization. We hope that the market is working as well on defining what are the premium for low carbon power, for low carbon products. So investability is a shared problem and probably a shared solution as well.
Excellent. Thank you, Julie. And Nick, I'd love to hear your perspective as well.
So from my end, I'm going to keep going down the investability route, but I'm going to look at it from stability perspective as well. So not just driving the cost down today, but creating the political environment that is stable to allow companies to invest in projects that are 20 to 30 years in kind of lifespan. I mean, we have seen in the last few years that some countries have put these projects into law, or at least the policies around them. And other countries, they've changed as governments have changed over. As an organization that's investing in projects, we cannot invest over a 25-year period if we find that the drivers and the policies change every 3 to 4 years. So for me, I think it's about getting stability in the investability.
Excellent. Thank you, Nick. And I guess I'll take a moment to chime in from a GE Vernova perspective. Completely echo everyone's comments on this, but definitely on Nick's around making sure that the policies are, extend and can support these long duration projects that are going to be in the market for 20 to 30 years. And that, the folks that are developing can have the confidence that I'll use the term rules of the game don't change in the next 4 to 5 years. And the other aspect, which I was actually very glad to hear from all the panelists, is we didn't highlight the fact that, the technology is not demonstrated per se, and that, this really isn't, a challenge of the technology. Carbon capture has been around for decades. But at least where I see some of the core challenges when it comes to combined cycle gas turbines, it's just fundamentally tied to the infrastructure. The ability to store these volumes of carbon is a challenge, and seeing that the wells and sequestration opportunities are increasing will help drive this market forward. And we do talk about areas and markets where carbon is hard to abate, like the steel industry. It's definitely challenging to put a well in just for one steel facility. But when you have a large project, like the Net Zero Teesside project, that's in part of an industrial cluster, it helps drive all of those common industries and markets to come together to then demonstrate or enable the investment in these sort of projects to have them go forward and be successful. So, that's where I see some of those key areas. And Jackie and Julie and Nick, thank you so much for your input. Thank you for your time today on the panel. Hopefully it was educational for our listeners. And I look forward to future discussions with you. Thank you all.
Thank you.